So in this video, I'm going along with the second worksheet, and I discussed how to use the concept of integration with the sigma notation extensively on the previous week. So I'll quickly go through this problem, and I'm not going to do all the problems in this worksheet. So instead I'll do part D, and you can do the rest in a very similar manner. And in this part we have to calculate the integral in between 0 and 1 of x cube, right? So what is the relationship between integral and the sigma notation? Now, as I said, I discussed this one in a very extended way in the previous video, so I'm just recovering those notations, and if you need to get a better understanding, please look at the previous week's videos. Okay, right, so we have delta x as this one, and the now there are like three methods of writing the sigma notation for integrals, and here I am using the right hand endpoints. You can even use the left hand endpoints, or else you can even use the middle points, which we discussed in the previous week. So now in this case, if I am going to use the right hand endpoints, to calculate the right hand endpoints, we have a rule like this, and accordingly for xj star it will be here a is equal to 0, b is equal to 1, so that will give you x star j as j over n. Then it is just a matter of computing the summation related with this integral, right? So how are we going to write the summation? We have all these theory parts were done in the previous week, right? So please have a look at those videos if you are struggling with this kind of symbols. And this is the standard way of representing the integral with the sigma notation, I mean the summation, and then you just have to plug in the corresponding values. Now here we consider f as x cube, and for the remaining problems use the corresponding x values, right? That's all you have to do, right? So accordingly we will have the sigma j from 1 to n f of j n, and for sigma you will have 1 over n. Now see, okay, now you can write another step, j from 1 to n. Since f is equal to x cube, whatever you use as the input, it will be cubed and given as the output. So we will get j cube over n cube multiplied by n, right? And this two n values in the denominator will give you j cube over n to the power 4. And there's another important step that you can use here. It's a very good observation. Now this sigma notation runs across j values, j equals 1, j equals 2, likewise, right? And n is not related with these j values. Now say for example, if n is equal to 10, what we have here is j is equal to 1 to 10 j cube over 10 4, right? So this is represented just as a number, but j has an important role inside the sigma notation, because the value of j will change term to term, right? But this does not, right? So since this is independent of the j values, it is true that the endpoint is n, right? But still it doesn't depend on j, right? So whatever the j value you have here, n will be the same, right? So like say for this example, if you expand the terms, what you will get is 1 cube over 10 4 plus 2 cube over 10 4. Likewise, 10 cube over 10 4, right? See, the denominator was the same for all terms because you did not have a j term, right? Therefore, you can just take the value n out from the sigma notation, right? And you can write it like this, and j goes from 1 to n. So this is a very important observation that you can make, okay? And this step will be used several times, right? So now in the question they have given you this standard formula, which is the sigma of j cube starting from 1 up to p will be given by this term. Say for example, if we start from 1 and end at 100 of j cube, that means 1 cube plus 2 cube plus 3 cube up to 100 cube, the answer of this one will be given by this simple term, right? This is a standard formula found by some mathematicians, so we can directly use it and you don't have to memorize those stuffs for any exams, right? Now see, in this case instead of p we have 100, and therefore we should have 100 squared 100 plus 1 squared over 4. So this will be a number. That means this number is the same as adding up all these 100 terms, right? Now we can use this formula to get rid of this sigma notation in our calculation, okay? And the only difference between this original one and this one is here the endpoint is represented by n and here the endpoint is represented by p. Other than that, everything is the same, right? Now, so I have this term outside, and for the sigma notation I am using this one, but replace p with n. Now see, here when you have 100 you replaced p with 100, but instead of 100, if you have n you should replace p with n, right? So in that sense it becomes n squared times n plus 1 squared over 4, right? Now we have get rid of this, we have removed the sigma notation and replaced it with some terms related with n. So what does this n means? That is the partitions or these small number of subintervals that we have in between the two limits, which we discussed in the previous week, right? So, and how are we going to relate this sigma notation to the integral? The theory is this one will be equal to this thing when n goes to infinity. That means when, now what does this n represents? That represents the number of subintervals, okay? The addition for all those subintervals. And when the number of subintervals goes to infinity, that becomes the integral, right? So the summation of infinite subintervals, the area of those subintervals when the number of subintervals is infinity is equal to the integral, right? So we just have to compute the limit of this value, right? n4 n squared times n plus 1 squared over 4, okay? And how we should compute the integral of this one, I mean the limit of this one? Since this is an infinite limit, just take out all the the highest powers from both numerator and the denominator, and you will end up with 1 over 4. So in simple sense, the limit of this one is equal to 1 over 4. We will discuss some more rules related with integration in later videos, but just this is the fundamental way of accessing the integrals. Okay,